Okay. Hello, colleagues. Again, my name is Oleksandr Reshetnik. Glad to meet you today and share my experience with extract, transform, load pipeline building with Google Cloud Platform and Dataflow. We are going to review a real case from my previous project. Before that, let me a short intro about myself and my location. I have been working in EPAM about 11 years. I'm responsible for Java competency in Vinnytsia in our central Ukraine cluster. Now our team is growing not only in Vinnytsia but also in Zhytomyr, Khmelnytsky. So if you would like to join to my team, just contact me and let's talk. And today I also present our Java and cloud communities from Vinnytsia. Last years, I work with API Competency Center and Integration Competency Center in EPAM. So usually I involved in API and integration projects in different areas and with different cloud providers and tools. Also, my area is developer portals and API platform building with Apigee and MuleSoft. I believe that clouds and managed services is our way to sustainable world. Modern world is data world. We have data sources everywhere. Our interaction with world produces more data. The internet and large-scale technological development have caused the explosive growth of data in today's world. Enterprise decision makers want to study the relationship between data, tap the hidden features of data, and analyze and explore the deeper levels of data. We need more and more compute power to work with data. And let's go to my story. One of our customers in the worldwide financial domain has a large ecosystem related to external integrations and operations of users. The ecosystem consists of different applications, processes, integration points. The ecosystem generates a lot of data stored in different places and formats. And when customer came to my team, the customer expectation was something like this. Please do some magic that makes daily reports from all of our data. Make our data more accessible, more convenient for investigation and exploration. In general, after the discovery, the problem was defined in such way. We need to build the extract, transform, load solution that gather different types of data from different data sources like SQL, NoSQL, databases, REST, and other data sources. Prepare data for business intelligence tools like Tableau or Data Studio or Looker. Has reliable and flexible architecture of the data pipeline. Provide a framework for data extraction and transformation from different sources. The orchestration engine for this data pipeline allows easy integration with other systems and allow result dataset review, discovery, and data mining. As you may see, all described fits to data warehouse concept. We have many data sources. We need to provide reporting and BI analytics. To achieve the goal, we need to build extract, transform, load pipeline, operational data store, also known as ODC, and data warehouse, or EDW. So we decided to follow the enterprise data warehouse reference architecture, but focus on building of ODC at the first phase and develop it to enterprise data warehouse if required. An operational data store is a central data storage that provides a snapshot of the latest data from multiple transactional systems for operational reporting. It enables organizations to combine data in its original format from various sources into a single destination to make it available for business reporting. And our assumption was that ODC will be enough to satisfy customer needs. The most challenging element of the solution was ETL pipeline that satisfy all requirements. With Odyssey approach, we have such benefits. A consolidated repository available for all systems. It unlocks more sophisticated reports. A consolidated view of data integrated from multiple systems. The up-to-date view into operational status. And it contains critical time-sensitive business rules for process automation that greatly improves efficiency. Yeah, sorry for this. I suppose other speaker tried his connection, so let's continue. Yeah, sorry, please mute if you can. Okay, and yeah, we selected this approach, and the customer was really happy that we proposed this enterprise data warehouse and operation data store idea. He was glad to see that we plan to follow reliable reference architecture, but reference architecture is too high level. Real implementation depends on diverse of components and constraints, and our customer has a lot of different constraints. The main constraint was that we should use Google Cloud Platform and a limited set of approved services. Fortunately, GCP has an excellent architecture for this case. The architecture supports multiple data sources. It is cloud native and serverless. Also, it's ready for machine learning tools and patterns. And in addition, GCP has a Dataflow, and excellent option for ETL part. Yeah, I love this sketch note from the Cloud Girl. I can look it for a long time. So let's get back to Dataflow. I believe you will review this chart later when you have time. Our Dataflow is a fully management streaming analytics service. It minimizes latency, processing time, and cost through autoscaling and batch processing. Dataflow is a data processing service for both batch and real-time data streaming applications. It enables developers to set up processing pipelines for integrating, preparing, and analyzing large-scale data sets. One more domain characteristic that fits to data flow paradigm is different nature of data that we have in the ecosystem. We had storages with data updated every day, but without some binding to time. Also, we had time-related data with incremental updates every second. We had big and small storages. Also, we had stable and variable data sets. And data flows allows us to build the Lambda architecture in data pipeline and work with all these different kinds of data with batch or streaming modes. And Lambda architecture allows you to select your mode of working with data. And Dataflow allows you to follow this Lambda architecture. One more advantage of Dataflow that from developer's perspective, Dataflow allows you to be engaged into development on different levels. You can develop a pipeline only with ready Dataflow templates without writing any code. Also, you can develop your pipeline on Java or other languages using out-of-the-box transformation from Apache Beam framework. Finally, you can write your own custom transformations on Java. Before review of the final solution, let's make a quick review of development on different levels. So there are a lot of ready Dataflow templates available in Google Cloud Platform. So you can build your pipeline without writing code at all for many cases. Most of templates are oriented on GCP Cloud Components. In most cases, if you only in GCP, it's enough and all that you may need. But also there are libraries with ready templates that can be added to your solution. So in GCP, you can import your own templates to Dataflow and use for building of your pipeline. But out of the box collection is also really powerful and can help you solve some easy and routine tasks. Let's review some example. This is some common tasks, the pipeline for processing logs to Splunk. You can create it on ready templates without writing any code. In this case, in this solution, we have just PubSub to Splunk template that takes logs from PubSub and sends to Splunk. We have cloud logging that push logs to PubSub, and we have our Dataflow job based on template that transfer logs from PubSub to Splunk. Also, you can customize your template with some user-defined function and add more flexibility to this logs transfer process. If you need more engagement, you can go to the next level. You can work with Apache Beam DSL level and write Java code using out-of-the-box elements from Apache Beam framework. There are a big number of different transformations. They are split on two groups. The first group is element-wise, that is used for every element in your data pipeline. There is a key element for creation of user-defined operations. This is a Pardue transformation that can accept user-defined code, user-defined function, and customize your data pipeline. And the second group is Aggregation Transformation group for operations on group of different elements. You can do something like average, mean, max, combine, and other group operations. And maybe the most valuable and most powerful thing is variety of I/O transformation for data consumption and data producing with different sources and destinations. It's really treasure because they allow you to connect your data pipeline to different data sources with minimum effort. And there are a lot of implementations for popular data sources. And this is only some out of the box set, but there are a lot of different libraries with additional components. And let's look to code. What kind of Java code could we have with different approaches? So With Apache Beam domain-specific language, you can get short, clean, and self-explaining code. For example, look on code that counts frequency of word in a file. It's a well-known word count example from documentation. So this pipeline created only with out-of-the-box transformations from Apache Beam framework. The pipeline consists of such steps, and you can easily read these steps in the code and see what happens on every step. So the first step, you need to read some text from file, then split this text on words, filter empty strings in this collection. Then you can count frequency of words in this collection, and you get a k-value map where k is word and value is frequency, number of occurrences. And after that, you need to filter, you need to format your out report. And when everything is ready, you can write result to the file. And this single screen of code. If you need to discover how to do similar thing on custom Java transformation, and when you need even more power from the framework, you can write your custom transformation with Apache Beam. Apache Beam is flexible and open framework and allows you to do it. You will get maximum flexibility and power, but it requires deep knowledge of the frameworks and how Apache Beam and Dataflow work. And definitely it will produce more code. For example, the same word count example, but with custom transformations and functions. And the pipeline looks cleaner and shorter, but you should remember that you need to implement every step on your own. So you first of all, you need a custom transformation that counts words. This is class that extend base p transform. And pay attention that transformation gets a collection of elements for processing. Also, you need custom functions that tokenize the file content. This is class that implements doFn base class. This class gets only one element for processing. In this case, this is a line from the file. And doFn child classes used in Pardo transformation for incorporating into pipeline. And finally, you need a custom function to format your pipeline output. And this function is used in the map operations from the first example. As you see from code, from all that I described before, Dataflow allows you to be engaged on different levels. And it depends from your task and requirements, how will you use Dataflow. And for our case, Dataflow was an excellent choice. And let's get back to my story and review the final solution that we got. So, the next important question from our customer was how to organize data pipelines from different data sources and allow other teams to build their own pipeline without support from our team. And the first choice was to build the separate and isolated pipelines for every data source. In this case, every new integration with data source requires full development engagement through all data pipeline. But as advantage, we got full isolation of every pipeline, so new integrated just cannot break anything in the solution. After some time and deeper dive, the customer domain, the approach was changed. It was simplified for next possible integration. We decided to remove final data load from integrator responsibility area. Now we have different and isolated pipelines only from original data source to intermediate storage. This pipeline depends from data source features. This pipeline is expected to be simpler than in initial approach. In general, it's expected to write only one small transformation pipeline. And as a result, we got a final solution in form of sliced architecture. In the first slice, we have different data sources. In the second slice, we have simple data flow pipelines that extract data and transform it to JSON line format and store in a cloud storage. And in general, the responsibility of every new integrator to create data pipeline in the second slice. In the third slice, we have pipeline that moves data from cloud storage to BigQuery. This is our main storage. And the final slice has integrations from BigQuery to BI tools. Also, between slices, we have additional integration points that allows inject data to the system. Such integration could be added to the intermediate cloud storage in BigQuery or even in a BI tool. So our integrator, any team that wish to interact with our solution can integrate on different level. It depends from their abilities and the data that they have. In addition, our possible integrators got an extension of Apache Beam framework for integration with our solution. We provided different types of converters, extractors from different data sources, custom integrations, HTTP client, and configurable loader to BigQuery. And after every new integration, after every new pipeline, this framework was extended. And as a result, at some point, new integrator could make his integration without writing any code by using ready templates. Let's summarize our result, our outcomes that we learned. Google Cloud Platform provides all possibilities for convenient and fast development and prototyping. Good documentation with examples, many videos, learning courses, live labs, community helps a lot also. It's really very valuable. It's really easy to prototype something quickly and check assumptions and hypotheses. For example, to build some draft of our system on premise can take about several weeks, but in GCP we was able to do it in several days. Dataflow is a reliable, fast, and powerful instrument for data processing. It allows you to be engaged on different levels. Serverless and decoupled architecture allows adjusting your solution design to customer needs at any time. If you're able to follow some verified approach, it helps in your communication with the customer and development. The customer was happy to see that we use reference architecture and some verified approach. Serverless approach allows boosting development significantly and remove DevOps and SRE overhead. Our sliced architecture with open integration points allows to build a solution open for extension with external teams. And designed in framework style with integrator in mind allows building reusable solutions with self-service capabilities. And thank you for attention. Hope my experience will be useful for you. If you have any questions, please contact me.
Hi, Alexander, one more time. Thank you a lot for a very interesting speech. I hope our participants have a lot of questions about GCP. So I want to invite you to the discussion table to tell more and answer all the questions. Thank you a lot.
Okay, thank you too.